So, first question of today's interview, what is an SQL injection attack?
An SQL injection attack. Can I share my screen? Is that okay?
Yeah, sure, go ahead if that helps.
Okay, so SQL injection, it's basically when we have a web page, right? And we have an input field on that web page. Let's imagine it that way. And basically the attacker, so this is our application. We have a backend, and the attacker is capable of writing SQL code over here. So they do write some SQL. Oh my God, I'm super zoom in. So they write some SQL over here, and that SQL gets actually executed because we failed to sanitize that input into our database. And they could do certain things, like they could probably, for example, change the privileges of their own user. They can read our database, they can drop the database. And this was a very common attack, I think back in the early 2000s. So basically what they would do is, I would write here some SQL, like select all from, but they need to engineer their queries very well. So for example, what they would do is they'll try different things, and you would start this statement with maybe a semicolon. And what that would do is that if in the backend, the way the backend developers go their queries was like this, like let's say they had a select all from users where username it's equal to, and you would normally do string interpolation with the input that comes from the front end. So you'd put directly the input here. The attacker could actually put this query that they put into here. And so you'd end up running SQL on the database. And the way to avoid this is to just use, first of all, sanitize all your input. And second of all, use SQL parameters. Basically, they look something like this. But what SQL will do when you send this query over and you provide this $sign argument separately, it will not run this as SQL. It will really, the query, the executable part of the query is this one, and then provide this as an input, and then it won't work. If they provide some SQL here, it's just going to, they will get no results, but it's not going to execute that on our database.
Cool. Now, we're going to move on with the second question. Can you explain HTTP caching? Right? And also go into advantages and let me know if you ever used it in the past later.
Awesome, sure. So HTTP caching, it's one of my favorites because it's very easy to set up these days. And basically, well, it's an HTTP mechanism, so it happens between a client and a server. And imagine we have here a CSS file or any other file, an image, a heavy file. We definitely want the users, we could actually make the web page load faster if users could reuse this resource in the future and not have to download it every time they go to the website. So what happens normally is, let's imagine this is our server, and there will be our client.
Yes.
And they'll make a first request of an asset. It can be even a REST resource, an HTML file. And so what they would receive in the HTTP headers would be a header called cache control. And there's different values for this header, but one of the most common is to basically specify, this is the header that specifies how the client should cache this. So basically here they would have something like, let me make this bigger, perfect. So we'll have something like public and a max age property. So max age, and this would be milliseconds. And what this means is the client can reuse that resource as long as the age of the asset, so there's an age, which starts at 0 when we just got it. As long as the age is smaller than the max age, the client doesn't need to get that resource. Basically, the web browser would store that on the computer and get the resource from there, get the CSS file from there. And that's basically the basics behind it. What would happen? What's happening when the age goes higher than this? Than whatever the max age was, is that the client will make a request, but it's not a request for the resource, but is rather to check if this is what we call caching validation. Is the resource still fresh? Is the resource still fresh? And basically they will do that nowadays with the E tag. So you probably have an extra tag, it's the E tag. And basically this is a unique hash that was computed for this version of the CSS file. And so they will send that to the server and check, was this modified? And the server can answer in two ways. They can either say, no, it wasn't modified, keep that version, or yes, it was modified, make a request, get a new version over. And back to your question on if I ever used it, this is basically most of times comes out of the box with any CDN you're using. So if you're deploying your application and you put a CDN in front of it, like a content delivery network, basically, they already apply this to all your static assets. They add e-tags, they add the cache control and the age. And we can even go in and look at the live example if you want.
Yeah, let's pick something like maybe GitHub or any like popular developer website.
Okay, let me see if I can share my screen again.
Now, one thing I want you to go over is this public parameter. What does public mean in that request?
Okay, so let's see how this looks like in Stack Overflow, for example. Yes, I'm gonna go over why I did that and what does that mean, but I just reloaded the page right now, and as you see here, it says 200 from the disk cache. So this is not coming from the server. This is coming from my personal computer, and the reason for that is that you see this. I'm not sure how big this is, but the age parameter here, the age, it's this many milliseconds, and if we look at the cache control, it's a public max age 315360. So basically, what this is saying is, hey, you can keep the asset for a bit longer.
Yes.
As long as this age goes over, they will rely on the e tag. So there's this e tag header that should be somewhere. Now, because there's no e tag, because I probably did not. Give me a second. Accept. Okay, I didn't really find the e tag. I think they might be relying on the last modified. Last modified, it's an alternative and expires. There are alternatives to e tag, but because it's so hard in programming to compare dates, and you need to always transform, bring them back to a time zone, it's just a lot easier to use the e tag. And so the modern way is to use e tags. Maybe if we look at another asset, like a CSS asset, they probably use.
I could see the e tag there.
There you go. So that's an e tag. But again, the cache control on this resource is no cache. So
okay,
even if we have it's not really being used. That's why I was looking for this one. That's a better example. But again, there's no e tag on this one. So it very much depends on how they perfect. It's pretty much, I feel like they're using an older setup, because they're using expire and last modify all the time. The other thing is, as you see here, if we enable disable cache, what we will be doing, and this is something really cool that Google Chrome does for us, is that whenever we get a resource, on the request headers, we are setting a cache control ourselves to no cache as the client. We're saying, hey, there won't be any caching happening.
Bypass the cache, right?
Yes, you could say that. We're actually using the headers to specify there is no cache. And because we do that, as you see cache control, no cache, then it doesn't really matter what the server implements. So just going back to the drawing, this is how HTTP caching works. I'd say a top view.
Awesome, Bogdan. Now let's move on with the next question. So imagine you have a huge SQL database. We want to scale that. So what are the different ways we can scale that huge SQL database?
Okie dokie, so we have one of those. I'm going to go back to my board just because it's a lot easier to show than tell. As a quick question, do we know anything about the traffic on this database in terms of reads versus writes, for example? Do we read a lot or do we write a lot? What is the use case?
Let's assume we read a lot more than we write, but as we scale, we will also face a writing problem down the road.
Okay. I mean, most web applications, you will read a lot more than you write. If you take the example of Instagram and so on, or any social media, people watch and consume stuff much more than they publish on average.
Yeah, that's a good news feed based application, like a social media. That's a good example. So you can use that. Yes.
Okay, so if that's the case, and we get a lot of incoming traffic here, and we figure out that the queries are getting slower, the memory on this component, the memory and CPU usage, it's blown up. What we can do is to basically apply a replication strategy that will basically, rather than having one database, we will have one database that handles the reading, and then we're gonna have a bunch of, let me copy this, a bunch of read-only replicas. So they used to be called master and slave, although right now we can just call it the main database, and then And basically what happens is we write to the main database, and whenever we write that, it gets replicated to the child, to the read-only replicas. But whenever we read from the database, we go to this cluster of read-only replicas, and so we can offload a lot of reading pressure to these replicas, and they're quite performant. And that would be one of the easiest way to scale the database by having read-only. Let me write it down here: read-only replicas. You can do this in AWS. I've done this with RDS. It's very straightforward, and it's one of the easiest way. Now, to follow up on what you mentioned as a second case, imagine we do need to write a lot. So we are getting to this point where this database, right, is getting bigger and bigger. We have too much pressure on the hardware, and we either add more hardware, which is usually a bad strategy, or what we can try to implement is sharding. So basically what we do is that we try to split into different databases based on a property that we hash. So for example, we have a bunch of records here, and then we take their, let's say, the ID, and then we somehow hash it. And you can think of this as almost a load balancer, although it's not really a load balancer, but based on the ID, we can actually push the record here or here or here. And whenever we need to read, based on the ID, whenever we want to fetch that, then they will redirect and read from the right database.
Getting into the distributed systems part, right?
Yes, this is a bit more complex to implement, and because you don't want to do this you don't want to write any application code. We don't want to couple the storage with our code. So this becomes a bit more complex to implement. You need to know about consistent hashing. And the hard thing about this is when you have joins, or when you want to query, you want to query records that are distributed over. Distribution, it's always a huge limitation, but if you want to scale, there's no way around it.
Yeah, you mentioned scaling it via hardware, right? Let's say vertical scaling. Right? This is an example of horizontal scaling. Why not scaling our database, vertically? Why not? Why distribute in the first place?
Very good question. The problem with vertical scaling is that it's going to become exponentially more expensive. The more hardware, so the difference between a machine that has, let's say, 16 gigabytes to 32 in terms of price, it's very high. And the other problem is you will most likely not need so much capacity all the time. You probably have peak hours. And so the problem once you scale vertically is that it's not so easy to go back. You need to shut down the server and then relocate to a bigger machine. Or even if you do it in the cloud, it's usually very expensive. It has downtime. And you still have a unique point of failure. That's another problem that can appear. So not only distribution, not only improves scalability, but also improves availability of the resource.
Mm-hmm. Okay, now we're going to go and talk about deployment. Could you explain the different deployment types? And as you explain them, feel free to dive deep into pros and cons, advantages, disadvantages. Different deployment types you've been exposed as a senior backend engineer. Okay,
so I'm going to start with the simplest one. We used to do this at the pretty much every startup you work for. That would be the in-place deployment. And this basically means that in one way or the other, we have our server, whatever that is, a Linux server, let's say, and we have our code that's, let's say, so let me make this green, let me make my code blue. And basically, we just kind of somehow replace the code with a new version. I'm going to put that green, right? So we somehow push that new version, and then we restart the server. I've done a lot of those, especially at the beginning of my career. It's very robust. It's very easy to set up. You just need to know a bit of server administration, but you do have downtime. So whenever you are restarting the application, there might be downtime, and it's extremely hard to roll back sometimes. So rollback can be a problem. And because you don't have a good rollback mechanism, downtime can be another problem. And also, well, it depends how you have it set up, but usually it's very, very manual. But this is like the good old-fashioned deployment.
And you need to stay awake until 2 p.m. when you have no users, right? Downtime.
Yeah, I mean, it depends on your traffic, but I did a bunch of all-nighters doing those, so
not funny. Cool.
Not at all. Then there's the rolling deployment, which is more or less the same, but the only difference here is that, and this is when it gets complicated, because you, let's say, have a fleet of instances, because we are horizontally scaling our service. Let's say this is our in Amazon, in AWS, they call this auto scaling groups, but doesn't really matter. You have a fleet of instances, and so what you do is you gradually deploy the new version of the software, right? So this becomes green all of a sudden, and this too. And then ideally there's no issues, and then you can continue. This is, again, it's kind of complex. The disadvantage is some people will access version 2 and some other will access version 1. So you can have problems there, especially if you have databases involved, because you need to also deploy migrations if you have SQL databases. So again, it's not great, but it is the only way you can deploy to a fleet of instances. The advantage here is if there's any problem with these two, you still have the other two alive. So you can maybe just shut this down really quickly and then instantiate a bunch of those really fast. So downtime, it's a bit less, but it's also, again, it's complex. You pay a lot of cost because you're distributing everything.
How do you distribute the traffic in this case?
So in this case, you have a load balancer component that sits here. And the load balancer is responsible for kind of distributing the traffic either with a round robin algorithm or whatever load balancing algorithm you choose. But again, the load balancer doesn't really know which version is it. So some users will go over there, some users will go over there. That's kind of the problem.
Let's go into pros and cons. So what I understand is there is no downtime. You just might get different users might get different versions, right? But here we avoid the downtime, right? Because we have this rolling strategy.
Yes and no. You can still have users that experience bad experiences, because if there's a mistake here, it's gonna affect them. So you have less downtime, but you can have problems.
Got it.
And this is what the next, like the blue-green deployment kind of solves. Blue-green. Right. So in here, we basically duplicate the whole thing. So rather than, imagine this is our old version, right? It's receiving traffic right now.
Yes.
And what we do is we totally deploy and provision a total copy of this with a new application. So let me just make this green. Okie dokie. And so that because we have two of them, we can actually make all our checks and then start redirecting traffic here. And if there's any problem, you keep alive this distribution and shut it down as soon as you see there's a problem. So this has literally, it shouldn't have no downtime. Like literally this has no downtime. No downtime. And the rollback, it's very fast because you keep this alive, and if there's any problem, you can shut it down. The disadvantage is you're going to pay a lot in your infrastructure costs. This can cost you a lot because you are duplicating this infrastructure and you need to keep it alive for a while. You also need to have a lot of complex tooling to be able to manage these load balancer components, to spin infrastructure really fast. So something like infrastructure as code can help you. But again, this is very complex. If you're using tools like Kubernetes and containers, you can set it up rather fairly quick.
Is there any more type of deployments that you'd like to mention?
There's canary deployment, and it's pretty much the same as blue-green, but there's a big difference, which is that you usually only redirect part of the traffic to our new instance. So you go ahead and you say, let me have 2% of the traffic over here, or 10%, or let me have the traffic from a specific geography. I worked with that a lot. And the other thing, the reason it's called canary is because you have a canary. You remember back in the days, the miners had a canary that they would send over to see if there's any gas leak, and the canary, if it comes back, then it's all good. The canary, it's usually an end-to-end test that's running all the time, and you run it against the new instance. And so if the canary it's okay, then you start redirecting more traffic. Again, you need a canary, that's number one, and complex load balancing setup because you want to redirect, you want to slice your traffic somehow. And number 5, I do not consider this a type of deployment. I know some people do, but that would be the feature toggles, where you're really not, you deploy the whole version, but you have some code logic that can switch a feature on and off. I do not consider this a type of deployment. For me, it's almost like a feature in the software, but some people do, and it has several advantages, which is that you decouple your deployment from your code deployment, like the deployment of the feature from the code deployment, but at the same time, having a lot of feature toggles really increments the amount of testing you need to do to your software. So I'm not gonna add it as an extra deployment.
Yeah. Next question: how does the internet works. And I want you to explain that, since the moment you type something into your browser until the page is shown, but until the page is rendered to the users, to the final user.
Okay, that's actually a very fun exercise. How does the internet work? Well, let's say it all starts, as you mentioned, with a web browser where we type something. Let's say we type the senior dev. So we type this in our web browser, and the first thing the web browser will do, it will make a query to look up the DNS, like the IP address of this of the server that's hosting this website, and they will make that to the DNS server, like the domain name system. The servers are basically like tables, so you just kind of think of a table hosted somewhere that says, the senior dev, let me see, has, so this senior dev, whatever, it has this IP address. So whatever. Okay, that's not the real IP address that I'm adding there, but you get the idea. So, and they have a bunch of them. And then the browser knows, okay, that's the IP address. And of course, this is the internet protocol. And so over the IP network, we can now start sending IP packages. Those IP packages are containing TCP packages, and TCP packages are put together in an HTTP request. So basically, when you type this address, you end up making a GET request to this path, to our domain, and I would assume the browser will send some headers too, like what does it accept, and most of the times it will be something like accept text/HTML. So it's basically requesting an HTML file that we have here. So that will be the request, and then there will be a response. So the server will open up a TCP connection with this, and probably reply with, ideally, if everything is successful, a 200 OK. And there will be some headers, but basically the headers will tell you what's the content type of our response, which would be text/HTML. And then there's an empty line, and then you have your HTML document. HTML, which is obviously it's just text, right? It's just a bunch of text, and then the browser will take this and see, okay, this is text HTML, so I'm gonna get all the body of the request here, and applies basically what we call the critical rendering path. So basically, it will take our markdown, it will try to build the HTML tree, it will request any links to CSS assets or JavaScript assets, it will interpret those, and then it will try to incrementally build the UI as it reads down the HTML.
Very good overview. We're not gonna go deep into the critical rendering path because that belongs more to the front-end engineering interview, but that's definitely a topic that is pretty interesting, talking about painting the final website to the user. Well, Bogdan, this is it for today. Very well done. Now, for the people watching us, if there's any specific backend question you want Bogdan and I to dive deep, just drop it in the comments and we will add it to our next video. That's number one. Number two, we are putting together a community for JavaScript software engineers that are looking to get to the senior level with quality resources, accountability. We have monthly calls where you can directly interact with Bogdan and I. We help you with technical interview resources, any kind of resources you need to make that jump to as a senior and beyond. If you want to check it out, just check the link in comments. You can apply, and we will, we have a bunch of people waiting to get in, so we will review your application. Just give us time and get you in if there's a fit. And finally, if you would like to work personally with Bogdan and I in a one-on-one group mentoring coaching program, right? This is what Software Mastery is designed for. We are helping developers fill up their technical gaps and become that confident, competent senior engineer. But we cannot work with any kind of developer. So this is a premium service. If you think that would be something you'd be interested in, just click on the link in the comments. Also, you'll find a link to apply for a small chat with me where we will see, hey, can we help you? Is this a fit? And see if we can talk further, whether you want to join us or not. With that being said, thank you so much, Bogdan. Very great answers. And we will see you folks in the next one.